Canada spent nearly 87 years completing a transportation system that once aimed to transform North America's inland shipping industry. Hidden deep among the forests and lakes of Ontario is a nearly 400-kilometer megaproject where engineers had to cut through solid granite, raise entire lakes above the ground, and even pull full-size boats onto railway tracks like trains. But while the Trent-Severn waterway was expanding section by section, railway networks across the country were advancing much faster and gradually overtook the inland shipping industry. By the time the system's most ambitious hydraulic machines finally began operating, railways had already become the new backbone of Canada's economy. So what ultimately happened to the project that was once expected to become a national transportation lifeline? Join Mandarin Tech as we explore the story behind the Trent-Severn waterway. On a map, the Trent-Severn waterway looks like a massive water route cutting across central Ontario. But in reality, this was never a natural waterway. The entire system, stretching nearly 400 kilometers and connecting Lake Ontario to Georgian Bay on Lake Huron, was assembled from hundreds of separate lakes divided by deep forests, rocky rapids, and enormous granite formations of the Canadian Shield. In many areas, there was not even a natural water channel for boats to pass through. It was almost as if they were trying to force the entire landscape of Ontario to function as one unified transportation system. And to make that possible, engineers had to turn the whole region into a gigantic water machine. After nearly a century of continuous expansion, the system eventually grew into a network of 44 locks, countless dams, artificial canal sections, and machines so unusual that even today they look more like science fiction than 19th century technology. In some places, Canada literally lifted entire lakes into the sky. But in more extreme terrain, engineers even pulled full-size boats onto railway tracks to move them across solid rock. The project began in 1833 and was not nearly completed until 1920, costing around 24 million Canadian dollars at the time, equivalent to more than $1 billion today. But while Canada was still struggling to finish the final sections of the system, the outside world had already begun entering the era of new mega-transportation networks such as the Panama Canal and transcontinental railways. What made the Trent-Severn waterway even stranger was this. It was never a fully designed megaproject from the beginning. In 1833, nobody sat down and planned the entire waterway the way the Americans later did with the Panama Canal or the French once did with the Suez Canal. For most of its history, Trent-Severn operated without a clear master plan. At first, logging companies only wanted to connect a few lakes so they could move timber out of Ontario's forest more quickly. But once a new canal section appeared, nearby towns began demanding more locks so steamships could travel deeper into the interior. Then politicians started pushing to bring the infrastructure closer to their own regions in order to expand trade and settlement. And so, each new canal section opened access to more resource areas, while also creating pressure to build the next section after that. For nearly a century, the purpose of the Trent-Severn kept changing, from logging to military use to commercial transportation. But the irony was that by the time the system was nearly complete, the thing traveling through it most often was no longer cargo ships, but recreational and tourist boats. Trent-Severn was never built as one complete project. It simply kept growing across generations, until even Canada itself no longer seemed to know where the true endpoint of the system actually was. When the first locks began appearing in the forests of Ontario in 1833, canals were still considered the future of North American transportation. But by 1885, Canadian Pacific Railway had completed Canada's first transcontinental railway. While engineers were still carving new canal sections through granite and lakes, railway networks across the country had already begun spreading steel across Canada. And with every year, the system expanded a little further. Locomotives outside were becoming faster, more powerful, and gradually taking control of the nation's entire transportation industry. While boats on the Trent-Severn needed days to slowly pass through dozens of locks, trains could move cargo across the continent year-round without being frozen by Canada's winters. And the harshest reality was that Trent-Severn was never truly built for the era of large ships. The system was only about 6 to 8 feet deep, far too shallow for many commercial cargo vessels. To travel across the full route, boats had to pass through 44 different locks, making the journey slow and complicated. The irony was that near the end of the project, the structures of Trent-Severn actually became more impressive than ever, as Canada began building some of the world's most advanced lift locks at the exact moment canal transportation itself was slowly becoming part of the past. Ontario's terrain gradually became a nightmare for traditional locks. The elevation differences between lakes kept increasing, more and more locks had to be built, and travel times for boats became significantly slower. Canadian engineers realized they needed something completely different, something bolder and powerful enough to overcome the massive granite formations of the Canadian Shield. And that was when the Peterborough lift lock was born. Instead of moving boats step by step through traditional water locks, engineer Richard Rogers proposed an idea that sounded almost insane at the time: lifting an entire lake surface and the boat itself into the sky. The structure officially opened in 1904 with a lift height of around 65 feet, nearly 20 meters, making it the tallest hydraulic lift lock in the world at the time, and also the largest unreinforced concrete structure in the world when it opened. To turn that idea into reality, Canada almost had to assemble a machine from the future using 19th century technology. Two enormous lift chambers holding thousands of tons of water, giant hydraulic cylinders, and massive steel structures all had to be specially manufactured and aligned with extremely high precision deep in the Ontario wilderness. In an era when modern cranes barely existed, most components still had to be pulled, lifted, and assembled using pulleys, mechanical jacks, and human labor. Even a small imbalance between the two lift chambers could destabilize the entire system. But after years of construction, Canada ultimately succeeded in creating one of the boldest hydraulic machines of its era. The most impressive part was how the entire system operated almost entirely through gravity and water pressure. Two gigantic lift chambers, each around 43 meters long, were positioned opposite each other in near-perfect balance. By adding only a very small amount of water into the upper chamber, the difference in weight would cause the whole system to move. One chamber descended, while the other lifted an entire boat along with thousands of tons of water, nearly as high as a 6-story building. The boat no longer passed through a lock. It almost seemed to rise directly into the skies of Ontario, but Peterborough was not the most critical point in the entire system. Farther north stood the Kirkfield lift lock, the structure located at the highest watershed point of the entire route. Without it, the entire waterway would have been almost split in half, because boats would never have been able to cross the system's highest elevation between the two sides of Ontario. It was not the most famous lift lock, but it functioned like the vital hinge that kept the entire waterway operating. If the Peterborough lift lock made boats appear to rise into the skies of Ontario, then the Big Chute Marine Railway turned boats into railway cars crossing over the mountains. In this area, the terrain of the Canadian Shield became too extreme. The slopes were too steep, the granite too hard, and the elevation differences so severe that continuing to build more traditional locks was no longer practical. If engineers had forced the canal to continue in the conventional way, boats would have needed hours just to pass through a short section of the system, and that was when Canadian engineers decided to abandon the logic of a normal canal entirely. Instead of traveling through water, boats here would travel across land. The entire process began when a boat moved directly into a gigantic steel cradle, dozens of meters long, submerged beneath the water. Once the vessel was secured in position, massive steel cables tightened and the motor system began pulling the entire cradle up the granite slope. Slowly, the boat, weighing dozens of tons, completely left the water. At the strangest moment of the journey, the entire boat was now sitting on a giant rail system and moving across dry land exactly like a real railway carriage. After crossing the highest point, the cradle slowly descended down the other side before lowering the boat back into the lake. The modern system, completed in 1978, could transport boats up to around 30 meters long and weighing dozens of tons. The greatest challenge was keeping the load perfectly balanced on the steep rail system of the Canadian Shield. Engineers had to calculate with extreme precision the combined weight of the boat, the steel cradle, the remaining water inside the vessel, and the pulling force of the entire cable system. Even a small imbalance could destabilize the whole structure on Ontario's slippery granite slopes. But the most fascinating part was that this strange structure accidentally created a benefit nobody had predicted beforehand. During the 20th century, the Great Lakes began facing an invasion of sea lamprey, a parasitic species capable of attaching itself to large fish and draining their blood, causing severe damage to both the ecosystem and Canada's fishing industry. Traditional locks were almost impossible to use as barriers against them moving between lakes. But at Big Chute, things were completely different. Because here, boats had to leave the water entirely in order to cross the dry land section. And the sea lamprey simply could not survive that journey. A technology that looked like a leftover machine from the industrial age of the 19th century ultimately became a biological barrier that continues protecting the Great Lakes to this day. And just as Canada was creating the boldest hydraulic machines in the history of the system, the outside world had already begun to change. By 1922, Canadian Pacific Railway alone was already transporting millions of tons of cargo every year across a railway network capable of operating across the continent in almost any weather conditions. Meanwhile, the Trent-Severn froze every winter. The Western Channel depth was only around 6 feet, making the system almost impossible to use for large commercial ships. And with 44 locks to pass through in a single journey, a trip that once took days by water could now be completed in just hours by railway. At that point, Trent-Severn almost had no chance left to compete. Transportation costs through the canal kept rising, while the speed was far too slow for the new industrial age. The waterway still carried some timber, agricultural goods, and local passengers. But as a strategic commercial mega-infrastructure that Canada had pursued for nearly a century, it simply never became what the country had once hoped for. And the most painful part was this: Trent-Severn did not fail because of engineering. In fact, it possessed some of the boldest hydraulic machines of its era. Lift locks capable of raising entire lakes into the sky, and marine railways pulling full-size boats across mountains were achievements that seemed almost impossible for the early 20th century. Canada spent nearly a century completing this system, but the era it was built for had already ended long before that. And yet the system never disappeared, because during those 87 years of construction, Canadian engineers accidentally created something even larger than a transportation route. The dams built throughout the system permanently reshaped the geography of Ontario. Water levels across countless lakes were raised. Rocky shorelines that once could not support docks suddenly became valuable waterfront property. Wetlands and remote areas that were once difficult to access gradually transformed into some of the most expensive real estate regions in Ontario. After nearly a century of building dams, Canadian engineers unintentionally changed the geography of Ontario forever. They never planned to create Ontario's famous cottage country. At first, all they wanted was a way to transport timber, cargo, and military supplies through Canada's interior. But this canal system ended up shaping how people in Ontario lived, relaxed, and viewed the northern lake region for more than a century. Lakes that were once remote and difficult to access slowly became some of Canada's most famous summer destinations. Granite shorelines that once had almost no economic value turned into expensive waterfront property. Marinas, campgrounds, and cottages appeared along the entire lock system. Small towns that once depended on logging and canal construction gradually shifted toward tourism, recreation, and lake culture. Ironically, the very structures once considered commercial failures now attract millions of visitors to Ontario every year. People come to the Peterborough Lift Lock to watch boats lifted directly into the sky using only the weight of water. They visit the Big Chute Marine Railway to see entire boats pulled onto land like giant railway cars. Machines once built for industry have now become real-life engineering shows. Today, the system is operated by Parks Canada as a national historic site. Most vessels passing through its 44 locks are now yachts, sailboats, houseboats, and recreational boats instead of commercial cargo ships. It also became part of the famous Great Loop, a 6,000-mile circular water journey considered a dream trip by many North American sailors. Trent-Severn never became the logistics backbone Canada once hoped for, but perhaps that is exactly what made it special. Instead of transforming North American shipping, it accidentally created the identity of an entire region of Ontario for more than a century afterward. Every summer, boats still line up at the Peterborough Lift Lock, cross the watershed at Kirkfield Lift Lock, and are pulled across railway tracks at the Big Chute Marine Railway. Trent-Severn never managed to defeat the railways or become the logistics backbone Canada once hoped for. It arrived too late for the new industrial era, but after nearly a century of construction, the system accidentally shaped the lake culture and cottage country identity of Ontario for more than 100 years. A mega project once left behind by its era, ultimately outlived the very things that once defeated it. If you enjoy crazy stories like this, don't forget to like the video and subscribe to Mandarin Tech so you won't miss the next videos.